For 10.4, we are going to take vectors and look at them more algebraically than we did in 10.3. So for this first part here, it's telling us that if we have points P and Q, then we can find vector PQ in component form by taking my x and y values in Q, subtracting the corresponding x and y values in P, and getting vector PQ in that component form. Remember that component form yesterday we said was just simply x comma y. So with these vectors, what we can do is we can add or subtract them as seen over on the left-hand side. So you're just going to take all of those components. If you're adding the two vectors, you add the corresponding parts. If you subtract them, you subtract the corresponding parts. Scalar multiplication, that was a word that we learned yesterday. You can just take whatever that constant k is, and you can multiply by both the x and the y component and get the new vector in component form. New vocab for today is unit vectors. The I vector is just simply going to represent our x, or our horizontal distance, and our j vector is going to represent our vertical distance. So if I have, say, the vector x comma y, that we can write as simply just xi plus yi. From here, looking at the examples that we have, this first one tells us to sketch and compute the length of vector 4, 3. Whenever you sketch vectors, we are always going to start at the origin, so at 0, 0. And then we're going to plot the point 4, 3 like we would normally. So go to the right 4, up 3, and that is going to be the terminal side of our vector. Remember, in order to compute the length, that is the same as computing the magnitude. And yesterday, we learned that that's simply taking the square root of my x length, or my horizontal length, and adding my vertical length, and then taking the square root of that. So that should be 4 squared plus 3 squared, all under the radical. And so this should end up being a length of 5. For a problem like number 2, it tells us to find the component form of vector PQ, given that P is the point 0, -4, and Q is the point 0, -8. Okay, so what we'll do here is first, let's go ahead and find vector PQ in component form. So I'm going to take the x components. I'm going to take my q values first and subtract my p values. And so if we simplify this, PQ is going to be the vector 0, -4. Moving on to a problem like number 3, telling us to take the magnitude of 4b plus 5b if b is the vector 5, 4. So what we're going to do here is we're going to work inside out. We can simplify 4b plus 5b and say that we're really taking the magnitude of 9b. From here, we'll do scalar multiplication. 9b is going to be 9 times that b vector of 5, 4. And so we're really taking the magnitude of this vector. 9 times 5 will be 45, and 4 times 9, 36. And so now when I take the magnitude of this, again, square root of 45 squared plus 36 squared. And so this is going to end up being square root of 3,321. And that should end up, we can take a 9 out of this. Actually, we could take 81 out of this. So this is going to be the square root of 81 and the square root of 41. And so this final answer should be 9 square root 41. Moving on to a problem like number 4, we're going to take vector A and add it to the sum of vectors B and C. So we're going to follow order of operations. B plus C, we are simply going to take our x values and add those together, and our y values and add those together. And so B plus C is going to be the vector 11, 3. And then if we go ahead and add A to that, we are going to end up having 2 plus 11, comma 3 plus 3. And so this will be the vector 13, comma 6. For problem 5, it tells us to express the vector 3, 8 in terms of unit vectors. Remember that unit vectors, those are our I and j. Since we have 3 horizontal values, we are going to have 3 of our I values. And then we have 8 of our y values, so we're going to have 8j. Going the other way then for problem number 6, it says express 5i minus 4j in component form. This is simply 5, comma, negative 4 with those arrow brackets. Last few problems that we have today. Number 7 tells us to find the unit vector in the same direction as 6, negative 3. What I want you guys to take note of, when it tells us unit vector, that's going to tell us that the length is 1. And so what we're going to do is we're going to find the length of the vector 6, negative 3 first, so the magnitude of that. And so that is going to simplify to the square root of 36 plus 9, which will be the square root of 45, which simplifies to 3 root 5. And so the unit vector, I'm going to take the length of the original vector and I'm going to divide 1 by it. And I'm going to use that as a scalar multiplication into the vector. So when I do that, we end up getting 6 over 3 square root 5 and negative 3 over 3 square root 5. And if we simplify this a little bit, that becomes 2. So we have 2 root 5 over 5. And we have negative root 5 over 5 as our unit vector, so it has a length of 1 in the same direction of 6, negative 3. So essentially I took that vector 6, negative 3 and I just gave it a length of 1 without changing the direction that it was heading. Okay, for a problem like number 8, it says if theta is equal to pi over 6, find the unit vector. This is something that we went over briefly yesterday. Remember how I said that my Vx is going to be equal to the magnitude of my vector times the cosine of theta, and Vy is going to be the magnitude of the vector times sine of theta. So this problem tells me I'm looking for a unit vector, so the magnitude of it is just 1. We just need to find then cosine of pi over 6 and sine of pi over 6. And so when we do that, we are going to have those values be our vector. So the cosine of pi over 6 is square root 3 over 2, and the sine is just 1/2. And that is going to be our unit vector with an angle measure of pi over 6. Similar to that one for number 9. This time now, theta is 2 pi over 3. So let's go ahead and find that unit vector. Again, magnitude is 1. So we are simply looking for the vector where we have cosine of 2 pi over 3, comma sine of 2 pi over 3. And when we do that, we get negative 1/2, comma square root 3.